Hello everyone, welcome back to Engineering Mechanics. Our discussion is on trusses. If you recall, in the last session, we discussed about structural analysis. You may recall, structural engineering or structural analysis is probably the oldest form of engineering that humans have practiced. The oldest human-made structure is still in France. It is about 5,000 years old, BC. Since the stone structure built long time ago to the skyscrapers that we are building now, we have made a tremendous progress in designing and building structures. There are various kinds of structures. Our focus today is on trusses. What is a truss? Well, truss is a structure that is entirely made of two force members. Now, you may recall what a two-force member is. Two-force member is a structural element that is either in tension or in compression. The loads are applied at the ends, at those joints. And typically, for two-force members, we ignore the weight. All right? So, a structure completely made of two-force member is a truss. Where are trusses used? Well, you see them in your everyday life. If you visit a supermarket or a warehouse, just look up. You will see lots of beams crisscrossing the entire structure on top, and those are all roof trusses. They support the roof. Similarly, trusses are also widely used in bridges construction. For example, a railway bridge. It's typically a truss. Here is an example. This is a railway bridge made entirely of two-force members, and therefore this is a truss. As you can see, here is a truss made of two-force members, and each three two-force members are making a triangle and more triangle, and this is a simple truss. Okay? Now, all these truss elements are connected at a joint, typically a pin joint, and those joints are here. All right? Now, these truss structures are so important that we see them in our everyday life, like railway bridges, roof trusses, and many other structures. When we also talk about structures, I want you to keep it in mind, it is not that stationary structures we are talking about. Moving systems such as a plane or an automobile or other transportation devices have also a structure, and those structures. Hello everyone. As we move on to talking about truss structures, let's briefly review two-force members. Remember, truss is a structure entirely made of two-force members. That's by definition, right? Otherwise, it won't be a truss. If there is a non-two-force member, a multi-force member, then that becomes a frame. It won't be a truss. And we are dealing with truss, which means all the members of the structure is made of two-force member. And what is a two-force member? Well, recall our discussion from the past. A two-force member is a member that is either in tension, as shown now, or in compression. All right? There is no other force applied anywhere along the line. And two-force members that make a truss joint are connected by pin joints at the ends. Now, these are all pin joints, and we are going to assume these pins are smooth. All right? One thing that confuses people a lot of time is, what about the weight? Remember, a bridge is a huge structure. It's very heavy. And even each member that makes that bridge is heavy. In our normal understanding, these could weigh hundreds and thousands of pounds. And yet, we do not want to consider the weight of that member, because if I draw the weight of this member, it's going to be applied somewhere in the middle. And if this is the weight and the beam is loaded here and here again, it is not a two-force member. This is not a two-force member. So, in our truss calculations, for that matter, any truss calculation, we are going to ignore the weight of that beam or weight of that member. Now, you may ask why we ignore it. Well, if you consider the loads involved in this truss design, the weight is relatively small and can be ignored for all practical purposes. And that's the reason we ignore the weight and still get a fairly good solution to the problems. Now, if you do have to account for the weight, then it can be done. What you do is take this weight, divide by 2, and apply at the ends. All right? So, again, to repeat, a two-force member is a member that is in tension or in compression, and the weight of the member is not accounted or ignored. And if you do have to account for it, you will have to apply at the ends, because by definition, a two-force member is loaded only at the ends, which means those joints. All right? And the last point I want you to keep it in mind is two-force members may not have to look exactly like a straight member. A two-force member could look like this. Okay? And if it looks like this, and let's say these are all the two joints connecting, then the line of action of the two-force member is line of action of the forces acting on the two-force member will be created by the lines connecting those two joints. All right. So in this case, this two-force member may look like this. This is just for you to know a two-force member doesn't have to look like a straight member, even though this would be the case for most part in trusses. All right. All right. So we are talking about trusses. We just briefly mentioned about two-force members. And before we go to trusses, I want to show you a simple two-force member made of a Lego beam. Here I have a simple beam. It's made of Lego, and it can be assumed as a two-force member, and it is going to be connected by 2 pin joints at these ends. All right? So I can find another beam. This beam alone doesn't make any structure. If I take this beam and attach to another beam, this is still not a structure. All right? So two-force members connected in this fashion is still not forming a structure, but let's say I take a third member and connect it now, I get a nice triangle, and see, actually I broke it. All right, watch this now. This is actually a rigid structure. All right, this is stable, rigid, and therefore a triangle structure is the simplest structure that is possible. All right. In fact, it is rigid, stable, and it is made of 3 members, 3 two-force members. So triangle structure is the simplest possible structure. And for those of you who you think, how about we make a structure with 4 members? If you look at 4 members here, clearly if I give a push here, this is losing its geometry. It actually collapses. So when you have 4 members like this, what you have is not a structure, it's a mechanism. All right? So if you want to make this as a structure, you need to put a cross beam making as a triangle structure. So if you look at trusses, most trusses are made with simple triangle members. For example, if you want to make a truss, you can start with a triangle like this. Now you know this is a simple structure. You can add 2 more members here, and you get another triangle, it becomes a structure. And I can add 2 more members like this, and you get another structure. 2 more members like this, 2 more members like this, and you can keep going. This kind of structures is known as simple truss. All right? And of course, the truss will be finally supported by maybe a pin joint and a roller joint. An example of such a truss is right here. You have seen it a few minutes ago. All right? That's a simple truss. Actually, it's a bridge. And you can see the truss elements made of triangles. All right. So that's how truss analysis is done. And truss analysis can be done in 2 different ways. One is method of joints. Method of joints. J-O-I. Joints. That's one method. Another method is method of section. 2 methods to solve truss problems. And the objective of truss analysis is to find the forces in each of those members. Are they in tension or in compression? All right. So your answer should include the member forces and In addition, you should include whether a member is in tension or compression. So let's do an example involving method of joints, and we will do this on the whiteboard.